There's another way that you can draw electrons, and it's probably the most accurate way to draw them. And it's using this kind of a look. Instead of drawing that big long line of boxes going across, you can actually also draw them in this lovely, not space-saving fashion. So this is the same thing as boxes. You don't have to use boxes. You can use lines. I often do use lines when I'm doing these on my own because it saves a little bit of time on the boxing. Remember, your electrons act as arrows. If you remember in this section, we were saying that these are the low energy. They're like held tightest by the nucleus because they're so close to the nucleus. And then as you go out, these ones are the higher energy, and they're like kind of crazy because they're so far from the nucleus. It doesn't have, the pull is just a little bit different from the nucleus farther out. So that also fits with this ordering. So remember, we were saying you fill the 1s's first. So notice how this is drawn more correctly because it's a low energy. That's the lowest energy. So this is low, and then this is high. And then as you fill, remember, this is interesting. The 2s within that same energy level, the s's are that spherical shape. The p's are like this shape. They've got this thing called a node, which does not help at all with energy. The electrons actually they show that the 2s or any s orbital is smaller, less energy than other shapes of orbital in that same energy level. So for example, when you go into the 3s, you can see that our 3 is all right in there. The s is lower than the p, which is lower than the d. So then as we fill in our s's over here, the next set of the s's, they fill, and then we jump to our p's, 1, 2, 3. So remember, Hund's rule, they're going to fill separately, and then we're going to pair it up again because we have 3 more. And so remember, they don't go like that. They pair oppositely because that's Pauli exclusion, but then they pair like this. And you keep going up. The other thing I wanted to point out is that something funny does happen right here before the 3D orbitals. It happens every time. The 5s will be just below the 4D. And it's kind of a little funny if you want to see a full chart for this all the way out to the Fs. But anyways, these electrons that are right in this section here are slightly lower energy, and this orbital is slightly lower energy. Remember the S shape. It's a very low energy shape. And so they're going to fill before the 3Ds fill. Remember, this is not an accurate picture of the atom. We don't have electrons on paths. We have them in shapes. These energies are not equally spaced as they are, but this is a picture that just kind of helps us get started talking about the atom that can actually be drawn and doesn't look too crazy.